5, 7 complex numbers and roots. With these, we're used to seeing square roots and taking square roots of negative numbers and saying that there's no solution. However, now we are going to be dealing with the letter I. The letter I literally just represents an imaginary number or an imaginary unit. So when you use this imaginary number, it's only when there's a negative underneath a radical where you're taking the square root, the fourth root, the sixth root, any even roots. So we look at some examples here. For example, 1a, we are simplifying. We have the square root of negative 64. So in order to turn this negative 64 into a positive 64, we're going to take an I out of it, and then we're going to take the square root of the 64. 64 is 8 times 8. That's 2, so it's just 8i. For b, we have 3 times the square root of negative 16. So again, this negative is going to be 3 times I times the square root of 16. The square root of 16 is 4. So that's 3 times 4i. Any real number always goes in front of that I. And this is going to give us 12i. For our next one, we have the negative times the negative square root of 75. So in order to take this negative out, we are going to take the I out front, and it's just going to be negative I times the square root of 75. 75 is 3 times 25, and 25 is 5 times 5. Group of 2, that 3 is left over, so it stays underneath. So this is just going to be negative 5i times the square root of 3. For D, we have the square root of negative 12. So again, that negative we are going to take out by making it a positive, taking an I out front. This is now just I times the square root of 12. The square root of 12, we have 12 is 3 and 4. 4 is 2 and 2. So group of 2. So this is 2i square root 3. For E, we have 2 times the square root of negative 36. So that I comes out. And then we have 2i times the square root of 36, which is going to be 6. 2i times 6 is just 12i. For F, we have negative 1/3 times the square root of negative 63. So in order to take that negative and bring it out, that becomes 1/3 I. The square root of 63, 3 and 21. The 21 is 3 and 7. Group of 2. So that's negative 1/3 I times 3 square root 7. Though negative 1/3 times 3 is going to give us negative 1i times the square root of 7. If we look at our next set of examples, we are now solving equations with these radicals. So we are doing the same thing that we did before. We are going to solve for x. Take the square root of both sides. When we take the square root of both sides, this square root shouldn't be there. This should be like this. So then we have the x is equal to plus or minus 9i, because the square root of 81 is 9, and then that negative gives us an I. For B, this one looks better. So we have that 75 that we're going to bring over. So it's 3x squared is equal to negative 75. Then we're going to divide each side by 3. So x squared is equal to negative 25. We take the square root of both sides. We're going to have x is equal to, we're solving for x and taking the square root, so plus or minus, that I is going to give us, that I is going to come from the negative, and the square root of 25 is 5. So it's plus or minus 5i. For C, we have x squared plus 48 is equal to 0. So again, we're going to move the 48 over by subtracting it from each side. So x squared is equal to negative 48. Then we're going to take the square root of both sides. We're going to have x is equal to the I times the square root of 48. The 48 is 4 and 12. The 12 is 4 and 3. We have two 4s, so this is x is equal to plus or minus 4i times the square root of 3. For D, we have 9x squared plus 25 is equal to 0. Move the 25 over. We're going to have 9x squared is equal to negative 25. Then divide each side by 9. We have x squared is equal to negative 25 over 9. We take the square root of both sides. We take the square root of the 25. We take the square root of 9. We make that the negative a positive by putting I in front. So this is going to be x is equal to plus or minus, because we're solving, the square root of 25 is 5. The square root of 9 is 3. So plus or minus 5/3 I. So sometimes we are going to have equations that are including imaginary numbers. When we have these, we are going to set the real parts equal to each other, and then we're going to solve. Then we will also set the imaginary parts equal to each other and solve. So we're going to have two answers here, an x is equal to and a y is equal to. So with these, our real parts are the 3x and the 6. Your imaginary parts are the negative 5i and the negative 10y times I. Take these two and set them equal to each other. So 3x is equal to 6, and negative 5i is equal to negative times 10y times I. Work with the 3x is equal to 6 first. Divide each side by 3. We get that x is equal to 2. For the other side, we can divide each side by I, as well as a negative, to make everything positive without working with the i's. So we're just working with 5 is equal to 10y. We divide each side by 10, and we get that y is equal to 1/2. So x is equal to 2, y is equal to 1/2. For B, we have 2x minus 6i is equal to negative 8 plus 20y times I. So our real parts are the 2x and the negative 8. So we'll put those equal to one another. And then our imaginary parts are the negative 6i and the 20y times I. We are going to start by dividing 2 on each side with this x to get x is equal to negative 4. Then with the other, we are going to divide each side by I. So this is going to be negative 6 is equal to 20y. We divide each side by 20, and we get that y is equal to negative 3 over 10. So y is equal to negative 3 over 10, x is equal to negative 4. For our next one, we have negative 8 plus 6y times I is equal to 5x minus I times the square root of 6. So our real parts here are the negative 8 and the 5x. So negative 8 is equal to 5x. And then our imaginary is the 6y times I is equal to negative I times the square root of 6. So we are going to start by dividing each side by 5 with the x to get x is equal to negative 8 over 5. For the y's and the i's, we are going to divide each side by I. And we're going to have 6y is equal to the square root of 6. Then we divide each side by 6. And we are left with y is equal to negative square root 6 over 6. Now you do not have a denominator here of 6. So you don't need to go ahead and rationalize your denominators here. You can leave it just the way you see it. For D, we have 9x plus y times I minus 5 is equal to negative 12i plus 4. So the 9x, the negative 5, and the 4 all get set equal to each other. So 9x minus 5 is on one side, and then that 4 is on the other. Then you have y times I is equal to negative 12i. So start with the x, move the 5 over, add it to both sides. You have 9x is equal to 9, then divide each side by 9. So x is equal to 1. For your i's, divide each side by I. We have y is equal to negative 12. We are actually going to skip the examples from example 4 Move on to example 5, because those examples in example 4, we actually have an entire lesson just on that. So we're skipping those and moving to example 5. Example 5, we are working with complex numbers written in the form of a plus bi, and we're finding the complex conjugates. So when we find the complex conjugates of this, we are going to move the real number to be in front and then change the sign between the two. So we have example A, we have 2i minus 15. We're going to move the real number to be in front, which is the negative 15. So it would be negative 15 plus 2i. Now we take the conjugate of this, change the sign of the term in the middle. So it's going to be negative 15 minus 2i. And that's it. For B, we have negative 4i. The complex the conjugate of this is just positive 4i. For C, we have 9 minus I. Our real number comes first, so just change the sign there. It's going to be 9 plus I. Oops. And then D, we have I plus 3. Your real number there is the 3, so we're going to move this to be 3 plus I. And then we're going to just change the sign in the middle of the two to be 3 minus I. For our last one, E, we have negative 8. So the opposite of that is positive 8. And it's just going to be 8i. For this section, we are dividing the exponent by 4. Once we get what our denominator is, or what our number is when we divide the exponent by 4, it's going to tell us what our answer is by using this chart up here, this coordinate plane. So the first one we have is I to the 13th power. So 13, we're going to divide that by 4. It's going to be I to the power, or it's really 13 divided by 4 is 3 1/4. You'd have 1 left over because 4 goes into 13 3 times with 12. That 1/4 is also 0.25. So look at your chart or your table. That 0.25, what is the answer for it? It's I. So your answer for this one is just I. For B, you have I to the 2nd power. Well, the 2 divided by 4 is 1/2. The one that's 1/2 is negative 1. For C, we have to the 47th power. The 47 divided by 4. 4 goes into 47 11 times with 3 left over. So that's going to be 3/4 with 0.75. Your 0.75 is negative I. And then lastly, your I to the power 24. 24 divided by 4 is 6.0 in decimal form. That 0.0 is the same thing as 1. And yes, you will have to memorize these.